Welcome to AskPrep, your trusted companion for NEET and JEE preparation. Today we will study about a very important topic of physics, which is alternating current, focusing on LCR circuits and resonance. This topic is crucial for your understanding of alternating current behavior, and mastering it will undoubtedly help you perform well in your NEET exams. To begin with, let's talk about alternating current, AC. AC is a type of electric current that reverses direction periodically, unlike direct current, DC, which flows in one constant direction. The voltage in AC also oscillates, meaning it continuously changes in magnitude and direction over time. AC is the type of current we commonly use in homes and industries because it's easier to generate, transmit, and control over long distances. When we connect alternating current to a circuit, the components in that circuit, such as resistors, capacitors, and inductors, react differently to the changing current. One particular type of circuit that we study in this context is the LCR circuit, a circuit that contains a resistor, an inductor, and a capacitor. These components each behave differently when exposed to alternating current, and understanding their interactions is key to mastering AC circuits. Let's start by looking at the resistor. A resistor is a component that resists the flow of electric current, and in the case of an AC circuit, it causes a drop in voltage. However, the current and voltage across the resistor are always in phase, which means they both reach their maximum and minimum values at the same time. The resistor doesn't store energy, it simply dissipates it in the form of heat. Next, we have the inductor. An inductor is a component that stores energy in a magnetic field when an electric current flows through it. In an AC circuit, the inductor opposes changes in the current. This causes a phase difference between the current and voltage, meaning the current lags behind the voltage. Essentially, when the voltage reaches its peak, the current is zero, and when the current reaches its peak, the voltage is zero. This behavior happens because an inductor resists changes in the current due to the magnetic field it creates. On the other hand, the capacitor works differently. A capacitor stores energy in the form of an electric field and charges and discharges as the voltage across it changes. In an AC circuit, the current and voltage across a capacitor are out of phase with each other, but in the opposite way to the inductor. The current leads the voltage by 90 degrees, which means when the current is at its maximum, the voltage across the capacitor is zero, and when the voltage is at its peak, the current is zero. Now, when we combine these three components, resistor, inductor, and capacitor, into an LCR circuit, the overall behavior of the circuit depends on how these components interact with each other. The resistance, inductance, and capacitance create different types of opposition to the current, which is known as impedance. Impedance is a measure of how much the circuit resists the flow of current, but unlike resistance, impedance also takes into account the phase differences between the current and voltage. The real magic happens when we look at resonance in an LCR circuit. Resonance occurs when the frequency of the alternating current matches the natural frequency of the circuit. At this frequency, the inductive reactance and capacitive reactance cancel each other out, and the circuit behaves as if it only contains the resistor. In this state, the impedance of the circuit is at its minimum, and the current reaches its maximum value. The phenomenon of resonance is a very interesting one, and it has many practical applications. For example, resonance is used in radio receivers. When you tune your radio to a specific frequency, you are essentially adjusting an LCR circuit to resonate with the radio signal's frequency. This allows the radio to receive and convert the signal into sound. Similarly, resonance is also crucial in transformers, where the transfer of energy from one coil to another is most efficient when the frequency of the current matches the resonant frequency of the circuit. However, while resonance is incredibly useful in many applications, it can also be dangerous in some cases. In mechanical systems, if external forces cause a structure to vibrate at its natural frequency, the vibrations can grow in amplitude and cause structural damage. This is why engineers need to carefully design buildings, bridges, and machinery to avoid resonant frequencies that could lead to catastrophic failures. So, what can we take away from this? Alternating current is not just a simple flow of electricity, it's a complex phenomenon that interacts with various components in different ways. The LCR circuit provides us with a rich environment to study how resistors, inductors, and capacitors work together to affect the flow of current. The phenomenon of resonance is especially important as it explains why certain frequencies have such powerful effects on AC circuits, enabling technologies like radio communication, power transmission, and much more. To sum it all up, alternating current, LCR circuits, and resonance are foundational concepts in AC circuit theory, and they play an essential role in many modern technologies. Whether it's in the radio signals we listen to, the transformers that help power our homes, or the careful engineering that prevents mechanical failures, these principles are at the heart of it all. If a structure, such as a bridge or a building, is exposed to external vibrations that match its resonant frequency, the vibrations can grow in amplitude and cause significant damage. This is why engineers must carefully consider resonance when designing structures and machinery. In summary, understanding alternating current, LCR circuits, and resonance is essential for mastering the concepts of electrical circuits and the behavior of AC. The way resistors, inductors, and capacitors interact with AC gives rise to some fascinating phenomena, including the powerful concept of resonance, which plays a crucial role in many modern technologies. By grasping these principles, you'll not only be better prepared for your NEET exams but also have a deeper understanding of how alternating current affects the world around us. I hope you've gained a deeper understanding of these concepts. Keep practicing problems related to LCR circuits and resonance, as they are likely to appear in your NEET exams. Stay tuned to AskPrep for more detailed explanations and tips for your physics studies. Good luck with your preparation, and see you in the next video.